Hello and welcome back. Today I'd like to talk a little bit about how to connect your LCR meter, because there are so many connectors available. We have little PCB boards, standard bananas, we have Kelvin with bananas, we have Kelvin with BNC, we have all kinds of BNC fixtures, and I just like to talk about it and why there are so many differences. There are a lot of different types available, and just have a look. I try to sort them a little bit. Later I will go through them one by one and when to use which one. Here we have the standard bananas. These are just for the standard multimeter and the simple LCR meters. And some even have the extra extension to put the PCB in, and then we can use this one. And then of course we have the Kelvin with 4 wires. And those we have in bananas, and of course also in different qualities with bananas as well. I will zoom in what is the main difference between these. And of course we have the same Kelvins, but also with BNC, and they also have a tweezer also with BNC 4 wire. And this kind of interesting also for multimeters, but I will tell you what's the difference with that one. And here we go to super professional. You pay a fortune for these things, and that has to do with the frequency, and you can measure your components directly, but it is very short closely to the device. I will come to that as well. And the professional version of the BNC we have here with, I think it's called Fixture, and that is in tweezer format, and that is also in the Kelvin 4 wire. Maybe very obvious, but when you have standard multimeters or even a little bit more advanced, you don't have much choice. You only have here the positive and the negative, and you probably will use your standard probes that come with it, or you use this shorter one, which is of course better, with banana to crocodile if you want to measure capacitance. There is simply not much choice, and of course you can also use the tweezers here, also simply with a banana plug. And what about if you have a dedicated LCR meter like here, the Handtech I have here? It also came with these, but we see here there is some sort of slot, and it looks like you can just put your components in there directly in the high and the low pot, but there are also special 4 wire Kelvin connectors. I have here one, I bought it separately, and you see it's 4 wire, but it's only connected to one side of the clamp, so you can think about this or not, but you need to match the guard with the guard and the high with the high, and then you connect it in here, and now you could have better accuracy on the lower capacitance. And why is that? And by the way, the suppliers of the LCR meters, I have here the East Tester, it is a higher model. This one is the 432. It came with both, and yeah, they are, as I say, they are improving, and here you can also see it came with both. This is a different one, but here you see it's also connected on one side and not on both. So I mentioned a little bit 2 wire, a little bit 4 wire. And why would you want 4 wire instead of 2 wire? Well, if we simply look at the resistor, which is kind of static, if we only are interested in the resistance itself, what you do with your multimeter, there is a very stable current going through, and then they just measure the voltage, and then depending on the voltage you can calculate your resistance. But you also measure your wiring of the cables that you are using, so you want to measure as close as possible to the device that you are measuring. So what does that mean? Well, simply we just measure a resistor. I don't know, I thought it was like 3 ohms in a bit, 3.3 ohms if I'm correct. Yeah. So what happens, there goes a current here, goes through here, and it measures the resistance. But we only have 2 wires. So that means we not only measure the resistor, but we also measure, because that's done internally, the voltage on this point. And we don't measure the voltage on this point. So actually it is not completely correct. And with 3.3 it is not that big of a difference probably, because how much resistance is in this cable. But if you measure a lot lower, it becomes a problem. So now we have this clip. But you see here are contacts and here are contacts. So instead of measuring the voltage, the current just goes through as normal on one side here, and then the voltage is measured on the other side. So instead of measuring the voltage over your device at the connector side, you start measuring it now where they come together, so that will be here. So that means that the resistance we lose is only in this little piece here, only in the connector here. And then of course we also have the Kelvin 4 wires with bananas, and these are great for your multimeter. Here also it is 4 wires, so one is for the current circuit and the other one is for the voltage to measure. So what if we do that with a sense wire here, and we put them right here. It doesn't say which is the current and which is the voltage, but in the end we see here it is again connected only to one side of the crocodile. I'm not sure if the crocodiles are also connected here in the middle with another wire. Oh, it seems it is. Look at that. Okay, so what they try to do is put the connector as close as possible, but again, because it is all the way here, it is both connected to the metal, so they bring now the contact point to here instead of to here. So that is a lot of improvement. 4 wire. And here we are actually pretty close also to this 3.217 that we saw also on the Handtech. So the Handtech wasn't that bad with the standard 2 wire, by the way, even. And what will we see if we do the same with 2 wire? Do we then also see a higher value? I can unplug these, but in the end it doesn't use it. And now we see a little bit more resistance, and that is the drop that we had. Let me relative this. And we actually see the same here, that it is higher now. This is what I would expect, and in the Handtech it was the other way around. So maybe on the Handtech, in combination with this PCB Kelvin, is not necessarily the best option, at least for static measurements like resistor as I did, because here exactly happens what I would expect, that it was the resistors a little bit lower when I was using the 4 wire Kelvin, and I saw exactly the opposite on the Handtech. So for resistance it's quite simple, we just do a DC current and then we measure the voltage. But if we want to measure capacitance, that doesn't work, because the capacitor will be very high resistance. Or if we do that with a coil for inductance, we see a very low resistance. So we can't really do that. So then we need to put a frequency AC, and that can be in the form of the triangle, the square, the sawtooth, or of course the sine wave. And I would think that if you use a square or the sawtooth, you can, instead of what you can do with all the waves, the phase shift, you can calculate maybe the value, but with the squares or the sawtooth, you have as an extra also the rise or the fall times that you can maybe combine with the phase shift and then calculate the value. So for DC it's actually quite simple. You just need 4 wires and you need to be as close as possible to the tip we are actually measuring, so the voltage you are measuring is correct. But now if we want to measure the capacitance or inductance, then we also need to deal with AC, so frequencies. And yeah, multimeters like this, or even the handhelds, they probably use 1K, 10K, that's all okay. But what if you have a more professional meter that uses higher frequencies like 100K or 200K? Then we need to be a little bit more careful what we use. And for instance, here I have a higher quality. This is from Ziboo, but it is sold on different other brands as well. I found this on AliExpress. You can also find it on Amazon. And what we can see here, instead of the normal cables, they use coaxial cables, and these are actually quite high frequency. And also when we look here, this is really both sides of the crocodile instead of on one side that we see here. Although I notice now there goes also a wire from here to here, so maybe this is also two sides, but you don't actually see that very well. Here you can actually see that. And we can see the metal plate inside and the spring. It's also connecting both sides. So this just seems better, and also I feel the spring is much more tight. So clearly there is also a difference between a Kelvin with bananas and a Kelvin with bananas. So I told you a little bit that handheld multimeters usually use lower frequencies like 1K, 2K, maybe maximum of 10K. If you go much higher, you probably need the BNCs that you sometimes see, and I come back to that later in the video. And with the bananas, I would think maybe up to 10K we're probably good. So that being said, I also wonder what multimeters actually send what signal. So I did also a little test on that. The Handtech uses a sine wave to measure this. And when you increase the frequency, it is still a sine wave, it's just faster. This one goes up to 40 kHz, and of course on the higher frequency you use your Kelvins. The Echelon seems to be using something more sophisticated. It is doing some sort of sawtooth, but it is also doing here some higher frequency things. Let's see what that is. It's a lot of little pulses. Also the Tektronix seems to do a little bit more sophisticated signal. Look at these little big ones, peaks, so they can better maybe read the delay or the phase shift or maybe the rise time change. Also the Fluke 287 does some magic here with little pulses in the top, and even if we look here, look at what it's doing. I was a bit surprised how advanced the signals look in the Keysight Echelon, the Tektronix and the Fluke. And how simple it was in the Handtech, and the Handtech, the only thing it needs to do is doing LCR. So now I wonder, I have here also my desk Rosui, or the Victor, and EastTester has a similar one, it's the same electronics. So I wonder how advanced this one is. And this one, just like the Handtech, is just a sine wave, no tricks with extra pulses. I'm surprised that it is so good and the signal is so simple. Now we have seen the Handtech, we also have here the ET432. It's newer than the Handtech, also newer than the Rosui here in the bottom. But it also, just like both, uses the simple sine wave. So apparently a little phase shift, or maybe somehow the sine wave changes, because you can't really do rise and fall times here because it's a sine wave. So not sure how they do that, but apparently they are very effective with this. So instead of a simple sine wave, most of the handhelds of the proper brands have really special signals to try to determine. So I wonder what this desk multimeter will do. put it in capacitors mode. Let's see what the signal looks here. This actually looks more like what I would expect, because you can easily measure the phase shift, and well, instead of rise time you can measure the fall time, and then the difference between that. What about the Keithley then? Capacitor. Okay, the Keithley looks very advanced. It seems to be a low frequency signal here and a high frequency signal. And here again a very steep fall, so they can measure the delay. If we go a little bit later, we can see here also the lower frequency signal. And here they probably also try to measure a phase shift. And because the multimeter, you usually cannot set your frequency that you want. It probably tries to measure with different signals, as we see here. And if one signal doesn't give the proper, it tries to scan on the other signal, I think. Quite smart. That's what multimeters need to do, because you don't set the frequency. Pretty cool, actually. And then I wonder what a real professional precision LCR meter will do. I will do a hands-on video on this later, by the way, on the DW Instack LCR 6002. It only goes up to 2 kHz, but it seems to be very precise, and it has a lot of digits. You can enlarge even your values. Pretty cool meter. I have here the Kelvin with the fixture. And let's see what signal comes out of this one. Well, in the first glance, it seems sort of like a normal sine wave, but when we zoom in a bit, you can see it's sort of modulated with the signal. Look at this, you see? It's modulated. So it is doing something with that. And then when we go a little bit to the more advanced devices, we can see that it is not banana, but it is actually BNC connectors. And you see that on most of the LCR desktop equipment. Like here, I have the GW Instack. It's not connected, so you can clearly see all the BNCs. And we kind of have the same here. Here is the force. I would think that is the current that goes over it, or AC current in this case, if we want to measure capacitors. And here we have the sense. So, and here with the sense, it is measured actually. The fact that BNC are used already means, okay, it's coaxial cable. We have a cable with shielding around. We want as low as distortion as possible. So again, here also the quality of the cables themselves, the coaxial cables they use makes a difference. And again, with some of these equipment, they go to 200 kHz instead of just the 10. And then you need even different stuff. Well, I have here my standard desktop LCR. It's quite nice. It also has BNCs. And we can see here it has the cables, but I'm not sure it's coaxial. And the cable goes underneath also to the other side. It also means that one cable is longer than the other. So I'm not so sure. This is what came with my meter. So yes, it goes up to 100 kHz. But usually it is on 1 kHz, so I'm not too worried about the quality of these cables. But of course we can do much better. Well, for the same quality we have here also the tweezers again, and that also works with the BNC connectors here. It is quite soft. I think it's shielded cable, but yeah, I'm not sure about the quality of this. But it is not too often that you need those high frequencies. Not high frequencies really if you want to measure really small, maybe below the picofarads, and then your cable impedance, your cable inductance, they all can play a game at some point. So then you're really good cables. Here again, these are nice, but again, one cable is longer than the other because one is soldered here, the other goes around here, and then is soldered here. And what if we are starting to use precision LCR meters? Then we need even better cables than that we have seen now. It's not necessarily the frequency because it only goes up to 2K, but this model is also available, I think, in 200K and in 300K. And if you buy it from Agilent, maybe they even go to 1 MHz. But we want to have as low as possible distortion because it's high precision. And then we're going to use cables. It's called like a fixture. And then we see the cables are sort of connected to a box, and it's called a fixture because you fix it to the front of your meter. So it goes here, you connect it directly, and it's a tight fit, and then you switch all your BNCs because it's bayonet, of course, and then it is stuck. Or a better word for stuck is fixed. That's why the word fixture. And this box also makes sure there is as less distortion as possible. And when I look at the Kelvins here, both the cables are the same length because they just both go to their own side and are connected directly. So this would be one of the most efficient ways. But of course this costs a little bit more money, and of course you can go crazy if you want. You can buy it also from Agilent or Tektronix, and then you probably need to sell your car. But this is possible. I think this one was around 50 euros, and it was also from Ziboo. And of course also available for tweezers. Same story here, shortly as possible, all shielded, proper stuff. So what if you want to measure in even higher frequencies? You want to go above this 200, 300K. Maybe you have an LCR meter that goes up to a megahertz. I think there are even that go up to 30 megahertz. And then your cables become so important, or even you cannot use cables anymore. And then you have these fixtures that you can connect directly. Well, then we have a fixture like this. Your component can go directly in here, and I even have a few adapters that I can change to have a smaller or a bigger distance, and it also connects directly. This one I think goes up to 1 megahertz, but then of course you need very professional equipment that I cannot do here in my lab. I simply don't have it, but I just wanted to show you what this looks like. This is already, I think if you look in eBay, they probably go around 150 euros already, so I cannot even imagine what this one from Agilent or Tektronix will cost that goes up to 30 megahertz or higher. So and what if you just want to measure resistance? You don't need to worry too much about AC components, you just want good resistance, and you find these normal Kelvins way too bulky and big, and the cables are not nice. Look at the difference between these clamps or these very well designed crocodiles. It is also possible, and you still have your 4-wire. The cables are super soft, and then you know, okay, for my 4-wire multimeter, this is also a great solution for resistor measurements. So it's clear there are a lot of cables available, and I hope, well, even though I'm not a specialist, I hope that this helps you decide which cable is maybe best for your purpose, for what you want to do, for what type of meter you have. Thank you for watching, and I hope to see you next time.